All right, so let's finish 4.5, the L'Hopital rule. Before we close this section, there is one more uh, type of questions I would like to discuss, which is called the indeterminate powers. Okay, um, the format might be you're gonna encounter to the power of infinity, or 0 to the power of 0, or infinity to the power of 0. Okay, and the central idea is, this is related to the exponential and the logarithmic. If we get stuck with exponential problems, we might want to take the logarithmic to convert it into a logarithmic problem, and then to deal with that and then convert it back. Similarly, if we have a logarithmic problem, we get stuck, we might transfer the problem into an exponential, and then problem might be solved, okay, based on a lot of properties about the exponential and the logarithmic. So in this type of the indeterminate powers, the idea is going to be very similar. We can take the logarithmic of those powers and then to deal with that and then use the properties and to convert it back. So, and this is also one of the conclusions we can have from chapter 2 when we talk about the limit problem. Okay, and it says like this. Okay, if we know that limit as x approaches a ln of fx equals capital L. Okay, in other words, if we know this limit, this long limit equals capital L, then this is what we can do. Then limit as x approaches a fx equivalent into limit as x approaches a e to the power of ln of fx, right? Because this is the natural exponent and the natural logarithmic, those are the inverse function of each other. So e to the power of ln of fx exactly equals fx. But look at what we have here, guys. On this part, we have ln of fx. And then, again, based on the properties of the limit, a limit of e to the power ln of x can be evaluated as e to the power of limit as x approaches a ln of fx. But look at what's the limit as x approaches a for this part is, which is capital L. Okay, so this limit as x approaches to fx equals e to the power of L. Okay, so it might be a little bit abstract if we only look at those conclusions, but now let's start with one example, and I think you will come. Okay. The problem like this. Okay, so show that a limit as x approaches 0 from the right. 1 plus x to the power, I think I missed one part, which is so 1 plus x to the power of 1 over x equals e. Trying to prove that. Okay, trying to prove that, and using the L'Hopital rule. And again, the basic idea is gonna be something like this. Okay, so we set. Let's see, starting to do the answer. Set fx equals 1 plus x to the power of 1 over x. Okay, and then what we can do is instead of to handling limit of this fx, this part, we take a natural logarithmic first. So in other words, we take ln of fx equals ln of 1 plus x to the power of 1 over x. Okay. And based on the property of logarithmic, realize that we can bring this 1 over x out, which on the right hand side it becomes into ln of 1 plus x over And so instead of to take the limit of this, we take the natural logarithm first, and then we take its limit. Okay, so limit as x approaches 0 from the right, ln of fx equals limit as x approaches 0 from the right, ln of 1 plus x over x. Okay, so we just prove this part. How do we handle this? Take a look. As x approaches 0 from the right, on the top, you have ln of 1, which is 0. On the bottom, you have 0. So you're going to have a 0 over 0 type. So we can apply the L'Hopital rule to deal with that. Okay, which is limit as x approaches 0 from the right, the derivative of the top, which is 1 over 1 plus x, right? Over the derivative of the bottom, which is 1. Okay. And so this limit is very easy to handle. In fact, you can just plug in, you will see that this equals 1. Okay, this equals 1. Okay, and once we have this, things gonna become very straightforward. Okay, because limit x approaches 0 from the right, 1 plus x to the power of 1 over x, then equals limit as x approaches 0 from the right, e to the power of ln of 1 plus x to the power of 1 over x. Okay? And this equals e to the power of limit as x approaches 0 from the right, ln of 1 plus x to the power of 1 over x. But what's the limit of this? It's right above, which equals 1. So e to the power of 1 equals e. So we finish the proof. Okay. And if you go back, we are exactly using this, right? This conclusion. So instead of to handle fx, we're trying to figure out the limit of ln of fx. And from this part, we conduct the L'Hopital rule. We got this. And based on this conclusion, the limit as x approaches the fx equals limit as x approaches the e to the power of ln of fx. We already know this part, which is capital L. So limit as x approaches the fx equals e to the power of L. Okay, so and then we can look at it again. Okay, guys. So we set this part to be a function fx. Instead of handle that, we take the natural logarithm on both sides, and then we take the limit. And we apply some properties about the logarithmic. We can see that ln of fx equals ln of 1 plus x over x. When we take this limit, this is exactly 0 over 0 type. We can apply the L'Hopital rule. And we get our conclusion, limit as x approaches 0 from the right, ln of fx equals 1. Then we can use those transformations. Limit as x approaches 0 from the right, 1 plus x to the power of 1 over x equals limit e to the power of ln of 1 plus x to the power of 1 over x. We already know the limit of this part from this step, which is 1. So this limit is going to be e to the power of 1 equals e. And then we finish the proof. Okay, so I'll stop here. Thank you.